My name is Radovan Kopecek from ISC-Konstanz, and now let's come to, let's say, the core of energy transition, which is solar cells, modules, and systems. I'm in PV since 25 years now, so I know all the up and downs of photovoltaics. And thank you, Erne, for the invitation. Actually, I have been already to your conference, I think 1.5 years ago, where we also talked about bifaciality, and now it's a continuation. And in my presentation, I will tell you more now about modules, which type of modules are now state of the art, and which type of modules you have to expect in future. And so I'm the co-founder of ISC-Konstanz and also one of the directors. In addition, I'm also a director in board of directors in UREC, which is an association of R&D institutes involved in renewable energies. And one of my major tasks these days is also to bring photovoltaic production back to Europe. And that's because we cannot just rely on imports from Asia. We've seen it during COVID crisis, and also because of the Suez Channel. We must actually also actively be involved in production of modules. But let me now come to the opening of my talk. Maybe you know it already. Solar is the new king of energy markets. And so if my relatives are asking me what I'm doing, I often show them this graph that I am in photovoltaics and making modules cheaper. So there is a very impressive graph, actually, that from 2009 to 2019-20, the prices for electricity production of solar dropped so fast that it's now one of the most low-cost energies out there. And last time we have been telling you that actually photovoltaics will come to 1 cent per kilowatt hour with bifacial tracking, and this became reality a couple of weeks ago. There have been the lowest cost tender now reported in Saudi Arabia with bifacial tracking of 1 cent per kilowatt hour, and this is simple amazing. And bifacial systems are growing very fast, and there is the largest bifacial systems now in Turkey from Kalyon, more than 1 gigawatt bifacial tracking system. So they are using bifacial modules which are active from both sides, and the bifacial gain here is actually 10%, which is a typical gain of PERC modules on trackers in a desert. And bifaciality is unchanged. The question is, how was it actually possible so fast to come to now 1 cent per kilowatt hour? And most of that is, of course, because of modules. And you see that modules in 2011, you see the power, the efficiency, and the costs. And sometimes the power is a little bit misleading because the substrate are getting bigger, and so the modules are getting bigger and bigger. But what I like to talk always about is the module efficiency. And the module efficiencies were increased from 16 to 20 to 20 to 23 now. So the modules are becoming extremely efficient and low cost. At that time, in 2011, they were about 1 to 2 euro per watt peak. Now they are available at 20 cents to 25, 30 cents per watt peak. So actually the modules are lower cost, modules are more efficient. And also what is important, that they are becoming naturally bifacial. So it's a natural development of solar cells and modules, because modules are becoming glass. So it's actually obvious to use the rear side. And of course, tracking is a very important thing there. And I think that already now in Hungary, already some tracking bifacial systems are planned. So what are the modules out there? And I have put you also the ranking of some of the modules, and you see various module technologies out there still with full cells, but these are, let's say, lower efficient, and of course shingling of the modules can give a higher efficiency, and or if you go to half cut. And so basically, let's say the most low cost and very efficient modules out there are so-called PERC, P-type technology, but the N-type technology like TOPCon, IBC, silicon heterojunction are ranked before them. So places 1 to 5 are actually N-type modules. At this time, they are, let's say, more costly per watt peak, but let's say the distance of the efficiency is getting higher, and the distance between the costs is getting lower. So to my understanding, I believe that in future N-type technologies will be more interesting for even for utility scale. And last week we published a new paper in Energies. It's about photovoltaics 2021, about bifaciality. And that's why I can show you some graphs from there, because it summarizes the situation quite nicely. So bifaciality became bankable, but that was not the case, let's say 5 years ago, because there were not precise simulations or large data from bifacial systems or bifacial standards. But this is now reality, and bifaciality became bankable. So now everybody can use bifacial modules because of the existing standards and simulation programs. So the last time we have shown you also that bifacial installations are growing. If you look at the map, let's say bifacial country number 1 is US, because they also dropped the import taxes for bifacial modules, which was a mistake by President Trump. They tried to put them back, but that was impossible. So let's say in US, it's a no-brainer to install bifacial systems, but also in Europe and Asia now the bifacial installations are growing. To explain you now how bifacial systems can be installed in a normal way, for example, also horizontally or vertically. This is quite an interesting system I will show you later. But let's say the system that gives you the lowest costs, the levelized cost of electricity costs, is the bifacial tracking. And in this table, you can actually see the bifacial gain compared to a fixed tilt monofacial systems, which is, let's say, 100%. If you put bifacial modules on a roof, you can get 5 to 15% more bifacial gain. In utility scale, because you are putting the modules higher up, it can be even 7 to 30%, and that's amazing. Can you imagine like 30% more energy yield with the same costs for the modules? That's simply amazing, I would say. But if you, for example, are using trackers in addition with bifaciality, you can have even up to 45 electrical gain. So the bifacial gain is about 20%. The tracking gain is also about 20%. And in total, you are not summing, but you are adding, you are multiplying the gains. So bifacial gains of 5 to 30% are possible. If you are also including a tracker, then you can have also 45% electrical gain. What is happening these days is that actually the substrates, and you have realized it, that the modules are getting bigger and bigger, and it's not always good to have bigger modules. It's good to have a module with higher efficiency. But the solar cells are getting bigger, because that's also one of the possibilities how to make the solar cells cheaper, because you know the machines they are handling solar cells separately, and if you increase the size of the solar cell, then you have a higher throughput in terms of watt peak, and that's why the solar cells are growing. In addition, they are not rectangular anymore, or they are not square anymore. They are actually rectangular, because that's a better shape of a solar cell. So not a square, but let's say slimmer stripe. And so in 2015, we had 3 bus bars, 156 times 156 millimeters square. Now 2020, so-called M6, is let's say standard, but M10 and M12 will be standard very soon, which is 20 times 20 centimeters. And so the cells are getting bigger, and also the cells are becoming more shallower. So you can do it in half cut or cut in 3 pieces. And this is actually the future. What you can also see is that the number of bus bars is increased to increase the fill factor. But I believe actually that the final solution is an IBC cell, where you have the contacts on the rear side, because that has the highest efficiency potential. On this slide, you then can find all the solar cells that are out there. And so here we have the P-type solar cells. There is still some aluminum back surface field, but this is fading out. Most of the solar cells out there are PERC, which can reach module efficiency now up to 21% and has a bifaciality factor of 60 to 75%. But as I told you, there are several other solar cell concepts like N-PERC, TOPCon, silicon heterojunction, and IBC, which are all N-type and having higher efficiency in the module. And this you can also see in that couple of these N-type cells have a better bifaciality factor. So not only a higher efficiency, but also a higher bifaciality factor. In addition, you have, let's say, lower degradation and a higher temperature coefficient, which also increases the electrical yield in your system. On this slide, you can see actually the typical module these days. And on this side first, that you can see the technologies as a function of the year. So the blue bars is aluminum back surface field, which is actually now fading out. So at the moment, 2021 to 2020, we have most of them, it's a P-type PERC. And you also see that N-type is now entering more and more the market. And I believe that in the next 2 to 3 years, it will be even more, because the efficiency potential is much higher. But the message here is that actually these solar cells can be all bifacial or are already bifacial. And this is then how the module looks like. You can have modules with frame, and this is preferred. Even if you have a double glass modules, frames are quite important, because then there is not so much breakage of the module. So that means double glass is a quite robust module, but for example, when it's about weight, then also transparent backsheet is quite interesting. Then you have shallow junction boxes, and mostly in the middle of the module. So actually the modules are now split into 2 modules, here module 1 and 2, which are then connected in parallel. And that's because also you can have a higher fill factor because of them, because also of the half cells. And I believe that in future, the solar cells will be N-type, multi-bus bar, and half cells. And now looking into the possibilities of installations. So we have installations, we have a matrix of possible bifacial installation, which is utility scale, rooftop, and integrated photovoltaics. All of them can be done, let's say, in fixed tilt, vertical installation, and tracking. And the applications are very different. So for example, in the utility scale, rooftop and integrated, looking at fixed tilt, you can have bifacial gains of 5 to 30%. The bifacial, if you choose bifacial modules or monofacial, that depends very much on the installation, because you can have also shading from the rear side. But fact is actually the bifacial modules cost the same as monofacial, only maybe 1 cent per kilowatt per watt peak more. And this is the same case with bifacial tracking. You can have tracking for utility scale, rooftop, and integrated. Here you have also, let's say, similar bifacial gains. And here you are also not paying, let's say, for the bifaciality. Only the front side power is sold. And that's the reason is because it's very difficult to put a number on the bifacial gain. And this is different for vertical installations, because if you install vertically east-west, then you have two front sides actually. So you have not a front side and a rear side, but two front and two rear sides, because the sun will always look at a different side as a front side as well. And here the installers are, let's say, paying also for bifaciality. And here it's very important that the module has a high bifacial factor. So for example, in TOPCon or heterojunction cells. And they are paying 1 cent per watt peak for 5% more bifaciality, more or less. So here I want to show you more about this, let's say, untypical installation, these vertical installations, because it does not make sense to make this with monofacial modules. This is done only with bifacial modules, and the advantages are that you have almost zero ground coverage ratio. That means you can use the land doubled, we can have electricity, and you can have agriculture as well. And with this system, you have electricity during the morning and late afternoon hours. You have a low maintenance system and also maximized energy during snow seasons. And you can see it here. When snow falls, sometimes you have problems with your systems, but here in vertical, you have no problems at all. Even you have a better albedo of, for the reflection. And so you can have a bifacial increase here even of 40%. And for this, there is Next to Sun, which is a company in Germany, now cooperates with Total, and they have a collaboration and are now installing such bifacial systems in Germany and France. Coming now to bifacial future, you can see actually from the International Technology Roadmap that they prognosed a very bright future of bifaciality, because as I told you, it's a natural development. And I already told you that at the moment, bifacial PERC is the driving horse. But in future, we will have more N-type and also bifacial tandem. And this is also what I would like to explain you how far this development is. First of all, let us look at the N-type technologies. I told you that they have higher efficiency and higher efficiency potential. However, the drawback so far is that they have more expensive wafers. The complex is more is more complex. And we are using more silver for this, and the silver prices are now growing, unfortunately. However, we are also working on reducing the silver usage. So let's say the cost of ownership at the moment are higher. However, the advantages are very pronounced, because you have higher efficiency, higher bifaciality, lower degradation, which results in higher kilowatt hour per kilowatt peak. So if we can reduce the cost of ownership, N-type modules will be used in future, because it's also, and you heard it before, it's about quality, and N-type modules have lower degradation. Now coming to my last point of the presentation is tandem. If you want to go above 30%, you can use so-called tandem technology, and the most promising technologies these days are perovskites on top of crystalline silicon. So you can imagine that the perovskites produce 20% and the light is absorbed, and the crystalline silicon is then producing about 10%. So not showing the full potential, but just let's say is used as a carrier, but also providing 10% of efficiency. And there are three different methods how to do that. Oxford PV, one of the leaders of tandem technology, are using so-called two-terminal tandem technology. Then let's say the other opposite is the four-terminal, where you have more or less like two modules on top of each other. And here you have the one semiconductor implemented into the other. So you have only, let's say, two polarities. And something in between, it's a so-called three-terminal photovoltaic cell, which you have an IBC cell, and on top of that you have a perovskite. And so the bottom cell, for this purpose, you use better silicon heterojunction or TOPCon, because you need a lot of voltage here, not to cannibalize the voltage of the perovskite. Here, the IBC cell, it's of course used because it's a 3-terminal concept. And in this case, you can use also, let's say, lower cost material because you just put two modules on top of each other. And that's a very simple solution. And these solar cells are, let's say, it's easier to make it monofacial because you need to make current and voltage matching in this device. Here, it does not matter. So for this case, you can have also a bifacial device. So I believe actually that the 2-terminal tandem will come on rooftops and the 3-terminal tandem will come, the 4-terminal for utility scale because it's bifacial. And we are organizing, or we are running now a tandem PV workshop, which is running in parallel, and it's also going until Friday. So if you are interested, you can also, for 50 euro, listen to the more details into tandems. And the last day of that is the industrial day, where we will talk about industrialization, what is still needed for tandems, and that's why I believe they will be out there in 5 to 7 years, because there's still a lot of work to be done. Stabilization of perovskite, upscaling of the production, also measurements and establishing standards, yield simulations, and also outdoor performance. Actually, you have to work still on the bankability, which is not very easy. So coming now to my summary and outlook, bifacial is gaining momentum. It is believed that until 2025, 50% of the systems will be bifacial because the bifacial modules are sold at the same cost as monofacial. The bifacial PERC, horizontal single axis tracker, now achieved the magical boundary of 1 cent per kilowatt hour in the MENA states. Bifacial PERC are now reaching 21%, and the costs will go down to 50 cents per watt peak, I believe. N-type technologies will come in the next 2 to 3 years because of higher efficiencies, and maybe in future, but this depends on many factors, mostly also on the stability of the perovskites. In 5 to 10 years, we could have 30% bifacial tandem technologies. And I would like to also invite you to our bifacial workshops. One will be in San Francisco and one in Antofagasta, I guess not face-to-face, but also via webinar. So let us move together to 1 cent per kilowatt hour. And if you have questions, just contact me via email. Thank you very much.